Okay, welcome to the discussion section for Math 126, Section 1.3. There was a lot of questions asked between the two classes, and so we'll kind of jump through these. Depending on how long it takes, I might have to cut this into two videos. That depends on, well, the equipment that I'm using has a 24-minute time limit before it cuts into a different file, and so I try to avoid that. But let's start with number 15. 15 asks you to multiply these two things together. They're two binomials, and so I would have to FOIL them, right? First, outer, inner, last. And so I'll take and distribute this root x times root x, but the square root of x times the square root of x is x, right? And then the square root of x times a negative 5 is negative 5 root x. And then the inner portion, 5 times the square root of x is plus 5 root x. And then 5 times negative 5 is minus 25. So we see these two terms in the middle are both root x terms. One of them is positive 5 root x, the other is negative 5 root x. They will cancel each other out. And you're simply left with on the outside this x minus 25, and that's it. That's the simplified solution. And that is 15. I was asked to do 17, which asks us to factor out the common factor. We have this w times w minus 3 plus 4 times w minus 3. And a lot of people hate to look at this the way it is, but if you, one of the common things that we can do in math is called a u substitution. Just let u equal this w minus 3 that you see in both spots. Right? And do this a couple of times if you need to, but get used to the idea that this binomial can be treated like a factor itself. But if I rewrite this with u in place of w minus 3, I get this w times u instead of w minus 3, plus 4 times that u. And I can pull out the common factor of the u, multiplied by that w plus 4. But again, I introduced a u, and so I need to get rid of that u back into w's, so I'm going to replace this u with w minus 3 again to get my w back. And I have it. This is the factored form. Most people just like to be able to say, hey, I can pull these binomials out because they appear in both terms, and it becomes w minus 3 times w plus 4. But this is the justification, step by step, how that all works. And that's 17. And we'll see this a lot. We're going to see this in a lot of, the factor by grouping type problems. We're going to see this pop up and come back with a vengeance later. All right. I was asked to do number 20 and 21, but they're very similar, so I'm going to do 20 and then let you go back and take a look at 21. 20 says factor. (3x squared) plus 20x minus 32. And in fact, we're going to see that method that we just did in number 17 appear in the method that we're going to use to factor this. Whenever you have a number in front of your square term, you're going to take it and the very last guy and multiply them. So I'm going to take 3, multiply it by negative 32. That gives me negative 96. And I'm going to take that negative 96 and find all the factor pairs that make 96. That is to say, I'm going to say, well, what is 96 divided by 1? I'm going to ignore the negative for a minute, but negative 96 divided by 1 is 96, and if it goes evenly, those are factor pairs. 1 times 96 equals 96, right? 96 is divisible by 2. You get 48 out of that. It's divisible by 3, and I get 32 out of that, right? And I'm just going to keep going down the list until, and I'm going to go in order, 1, 2, 3, 4, 5, 6, 7, 8, 9, until the numbers down here, there's nothing between them, right? And the reason then I can stop is because I don't have to check all of the numbers between, like, let's say 48 and 96, because if there's a number that 96 is divisible by between between 48 and 96, its factor pair will be between 1 and 2, but there are no integers between 1 and 2, so I don't care, right? So I already have a huge chunk of my numbers I don't have to check anymore. But I'm going to keep going until I can find a factor pair that will give me 20 when I combine them. So I don't have that yet. Let's take a look at 4, 4, and 24. Looks like I can stop here because I need these to multiply to be negative 96, and I need to add them to be positive 20. And if I let 4 be negative, that'll do it. Negative 4 plus 24 gives me the 20. They add to give me this middle number. Negative 4 times 24 multiplies to give me negative 96. These are my factors I want, and I don't even have to continue. There are more, but I don't care, right? And what I'm going to do is then replace this number right here, because these two numbers add up to be that number. I'm going to replace this term with terms with those coefficients. So that is to say, I'm going to change this to be 3x squared. And instead of plus 20x, I'm going to write it as minus 4x and plus 24x. Right? I'm going to break it up strategically this way, minus my 32. And the reason that I did that is now I can factor this by grouping. Group the first two, group the second two, and pull out the greatest common factor from each group. I can't pull out a number, 3 and 4, and nothing in common, but I can pull an x. So if I factor out an x, that leaves me with 3x minus 4, right? What can I pull out of this guy over here? An 8, right? And that's it. So I pull out an 8. 24x divided by 8 gives me 3x. 32 divided by 8 gives me 4. And again, we can see we've got this 3x minus 4 that is here, 3x minus 4 that is there. I can pull that out as it's a binomial factor, right? But it's common to both of these terms. I'm towards the bottom of my screen here, so I'm going to move this up and get rid of my factors here. Well, in fact, all I really have to do is write the answer at this point. Because if I factor out 3x minus 4, what's left when I do is I pull that out, I'm left with just an x plus 8 as my other factor. And that's it. And again, you'll find that 21 has a very similar process. You'll go through very similar steps for 21. So give it a try. It's good for you guys to have one that you're not walked through. Let's take a look at 22. Twenty-two says factor. Oh, 22 is very similar to this as well. So it says factor. I have 5x plus 1 squared. But it's different enough that it's worth knowing. Minus 5 times 5x plus 1, and then minus 14, right? This one's a little bit weird because I have that 5x plus 1 here, I have it here, but I don't have it here, so I'm not pulling it out like it's a greatest common factor, like we just did. What I can do is use that u substitution. If I say, you know what, I don't like the way this looks, I'm going to let u equal 5x plus 1. Right? Well then 5x plus 1 squared becomes u squared. Minus 5 times, instead of 5x plus 1, u. And then minus 14. And this looks a lot nicer, right? In fact, I can factor this right from the get-go. There's a 1 in front, so it should be a quick, easy factor of 7 and 2. The 7 is negative to make the negative 5 here. And so I get u minus 7, u plus 2. and I'm done with the factoring. However, I'm in U, and I don't care about U. That sounds harsh. I don't care about the variable U, I care about x, right? So I need to go back into x. U is equal to 5x plus 1, so I'm going to replace each of my u's with 5x plus 1. Oops. I'll do that over here. 5x plus 1 minus 7. And 5x plus 1 plus 2. And then simplify. Plus 1 minus 7, that gives me 5x minus 6. And then 5x plus 3. And I'm done. All right, let's look at 24. And I know I'm going through these a little bit fast. You have pause buttons. Use them if you need to, but let's go. 24. 24 is 49 times t plus minus 1 squared minus 9. Right? And we're supposed to factor this, right? And the worst case scenario, you can take this t minus 1, square it out, multiply the 49 through, and then factor the resulting trinomial. But you can treat this as the difference of two squares. This whole thing is 7 multiplied by t minus 1 that got all squared. If I were to distribute this square through this expression, that would be 49 times t minus 1 squared, right? This one over here is just 3 squared, right? And so recall with these a squared minus b squared, that's the difference of two squares, something squared minus something else squared. This turns into a plus b multiplied by a minus b, right? That's the difference of two squares. It's the quick, easy way to just get to your answer by remembering this formula. And so I know what a is. A is 7 times t minus 1, and I know what b is. B is 3. So my answer then is a, or 7 times t minus 1, plus 3, multiplied by 7 times t minus 1 minus 3, right? And this is correct, not simplified, right? So I need to simplify a little bit. I'm going to take the 7, distribute it through, and I'll do that on each one. So this becomes 7t minus 7 plus 3. This becomes 7t minus 7 minus 3. And then I can simplify these. This becomes 7t minus 4 and 7t minus 10. And done. Okay, 26. I think I'm going to make it. Yep, I'm good. All right, 26 is a little bit larger one. It says to factor. I have x to the third minus 6x squared plus 3x minus 18. And since there's 4 terms, it tells you to do it by grouping, but since there's 4 terms, that's essentially all we'd be able to do here. So I'm going to group this, take a look at the first. And then the second is here. My greatest common factor from x to the third and 6x squared is just an x squared. So I'll pull out an x squared. And that leaves me with x minus 6. Plus, all I can pull out from the second group is a 3, so I have a 3, and then I get x minus 6. Thank goodness, because if I didn't, I would have nothing to continue with. but I have an x minus 6 that appears in both terms. That binomial factor can pull out. That leaves me with x minus 6 multiplied by x squared plus 3. And that's all I can do. I have an x squared term here, but it's a plus, and it's not a square over here, so I can't factor this down anymore. That's my answer. Alrighty, let's look at 27. 27, I think, was very commonly asked, what the heck is going on here? 27 says to factor by first pulling out the lowest power of the common factor. We're given w to the 7/3 minus 9w to the 1/3. So each of these terms has some w's, and the smallest power of w is to the 1/3. So what I'm going to do is take out w to the 1/3 and factor that from both terms. And when I factor, remember factoring out is like dividing it out. And so what's left here, the first term, is whatever w to the 7/3 divided by w to the 1/3 is. So if we think about what's happening is I have w to the 7/3 being divided by w to the 1/3. But that's just w to the 7/3 minus 1/3 as the power. And that's 6/3. And 6/3 is 2. So on the inside, no more fractions in my exponent, it's just a 2, right? Now when I pull it out of here, the w to the 1/3 gets divided by the w to the 1/3, it's just gone. All I have left is minus 9, right? So with this division here, now all of my yuck, all of the fractional exponents are hanging out here, and I'm done with these. You can be there all you want. The only thing that's left is now I have a difference of 2 squares here. So I'm going to get rid of this, say goodbye. This w to the 1/3, don't lose it, it's still there, but it's now multiplied by the factor part of w squared minus 9, which is w plus 3 times w minus 3. And the answer, I don't know what it says, it might be plus 3 minus 3 or minus 3 plus 3. It doesn't matter, right? They're the same thing. There we have 27. Okay. 28 is similar. I'm going to go through it because, again, it's similar but just different enough that it can be confusing. 28 says to do 50f to the negative 1/2 plus 15f to the 1/2 plus f to the 3/2. And we're going to go through that same kind of tactic where I'm going to find the lowest power of f and pull it out. But this is where it gets a little crazy. Let me make sure I'm not going to get cut off. Oh, all right. The smallest power of f is f to the negative 1/2. So that's what I'm going to pull out. Pull out f to the negative 1/2. And what's left is that, again, it's a division, right? So I'm going to divide each of these by that f to the negative 1/2. But f to the negative 1/2 divided by f to the negative 1/2 is just 1. Something divided by itself is 1. So it's just times that 50 that's left over. So 50. Now it gets a little bit weird here. I'm going to do this out, right? 15. I'm not worried about the 15. Nothing's going to change with the 15. But what goes here as the powers of f is f to the 1/2 divided by f to the negative 1/2. Right? Or f to the 1/2 minus a negative is a plus. Right? There's that double negative, that negative 1/2 is like coming up into the numerator as a plus, so I'm really going to add these guys. 1/2 plus 1/2 is 2/2. Or just f to the 1, which is just f, right? So this 15 is tacked on to f. I'm going to delete that work over there because I need it to do the next one. In fact, actually I'm not. I'm going to cheat because to do the next one I just have f to the 3/2 over f to the negative 1/2. And so I have f to the 3/2 plus 1/2. But 3/2 plus 1/2 is 4/2, which is 2. And so my last term is f squared. So it's sneaky, maybe. It's tricky, definitely. But I now have this. And I'm actually going to take this entire trinomial and reverse its order. And so I still have this f to the negative 1/2. But writing the trinomial in descending order gives me f squared plus 15f plus 50. And now I'm just looking for factors of 50 that'll add up to 15, like 10 and 5. That'll do it. And so I have f to the negative 1/2 times f plus 5 times f plus 10. And again, it doesn't matter which order these are in the answer. It might be f plus 10, f plus 5. It doesn't matter. But that is 28. Thank you, and I'll see you next time.